Hello, everyone. Welcome to the AI Customer Excellence Center, or AICEC in short. My name is Francis Han. I lead AICEC for Oracle JPAC region. One of the things I do in my role is to conduct discovery sessions with our customers in which their pains and aspirations are discussed, and I try to link them to some viable Oracle solutions. This is the place that we host customers. It's meant to be compact, cozy, and conducive for a relaxed discussion. We have a barrister in our office, and we can fix you a nice warm cappuccino or latte. And we set up showcases related to some AI technologies to spark some ideas about how we can leverage them for your operations. You'll notice a big whiteboard, which is where we spend most of the time with our customers to brainstorm and jot down problems, use cases, and solutions. First of all, I'd like to go back in time to 1963. Let's say we are trying to get from point A to point B with no Google Map and getting lost on the road. You could either use a physical map and a compass, or you could call a navigation hotline to get help. That is the Google Map of 1963, by the way. About 10 years after this picture was taken, in 1973, the GPS was invented. The GPS pretty much took away the jobs of these people. And this is one of the many recurring examples of how technology transforms our jobs and the way we work. A phenomenon that we keep witnessing since the Luddite movement in the 19th century, where textile workers in the UK raided factories and destroyed machines for taking away their jobs. Next, let's look at another interesting technology transformation that has helped us all these years. 20 years ago, it used to take about 8 to 12 man-hours to bring 1 carton of milk from a farm onto a supermarket shelf. Today, it takes 1 to 2 man-hours. That is a very drastic reduction, not just for the man-hours, but for the price of 1 carton of milk. This is possible all because of the automation that has gone into the processes at a farm, at a factory, the warehouse, and the supermarket. If it's still 12 man-hours at today's labor rate, then not many people can afford to drink milk. And the same goes for the meat, the bread, the fruits, etc. At AICEC, we strive to do just that, to help cut down the inefficiencies in processes across the industries. We help to close the gap between the operational challenges and AI and data technologies. Our mission is to help customers accelerate their AI transformation journey. Now, let's get back to the real world today. This is how machines see the world, detecting and locating objects of interest, objects such as pedestrians, road signs, cyclists, etc. Machines can be multimodal too. They can take in different data types like video, voice, process them and output in different forms. Machines employ techniques like object detection, speech recognition, face recognition, etc. And all these solutions are not new. They have been around for decades. But the underlying technologies have been evolving. Today, with AI models, we can get machines to understand our world better. Most importantly, we can apply some industry use cases with this understanding. For example, in workplace safety, where we can detect whether the worker is properly geared up for the job. Using the appropriate AI model, we can look out for workers not wearing their helmets or vests properly and take action before bad things happen. We have seen a computer vision use case. Next, let's look at a use case involving a chatbot. Here, we can either use text or speech. Behind the chatbot is an agentic system which has some tools at its disposal, connecting to real-time traffic information and some documentations. It is also capable of language translations. Let me test it with a question. I am heading from Bishan to Raffles Place. Which route should I take?
Based on current conditions in Singapore, overall traffic is free-flowing with no major road closures.
From Bishan to Raffles Place, you typically have two main options. One, a Pondaland
By MRT, usually the fastest and most predictable. Take the north-south line red from Bishan MRT towards Marina South Pier.
A light at Raffles Place MRT?
No line changes needed. Total travel time is usually around 18 to 22 minutes, plus walking.
2. Kambi has to point a 1-1. That about the one on me?
By car taxi private hire, given free flow traffic. Common fast routes via CTE U Tong Sen St. Newbridge Road, Raffles Place, or via CTE I Central Boulevard, Cecil St., depending on your exact drop-off. With current free flow conditions and normal signals, expect roughly 12 to 20 minutes travel time, depending on time of day and exact start. See and points. Recommendation. If you are near Bishan MRT, take the north-south line directly to Raffles Place for the most reliable timing.
If you already have a car taxi, follow your map app's suggested route via CTE. With traffic currently free-flowing, its fastest suggestion is safe to follow.
One thing I would like to mention here is that at AICEC, we do full-stack AI. That means we don't restrict ourselves with any pillar of AI solutions, but we prescribe the most appropriate solutions to a particular problem. Let's look at AI from a 20,000 feet view and see how far we have progressed so far. AI went through some winter periods where there were not a lot of investment, not a lot of research, and not a lot of interest. The winter periods happen mostly during the period of machine learning, a period where we relied on some algorithms to do classifications and predictions. That was very helpful for various industries. Insurance companies could charge their customers different premiums based on their age, their driving experience, their accident record, and what type of car they drive. Do they drive for the thrill or speed, or they drive to get from point A to point B? As you can see, machine learning relied a lot on features like age, years of driving, etc. Based on these features, machine learning algorithms can make predictions, do classifications. Stockbrokers could make predictions about their stocks. Manufacturers could predict their inventory. Retailers could recommend relevant products to their customers. Banks could segment their customers, and engineers could predict when machineries will fail. Machine learning could help industries make predictions, but there were some limitations. Back in 2008, I was talking to a customer who wanted to implement a facial recognition system. They had to abandon the project because accuracy wasn't great, around 50%. That means half the time you get the answer wrong. Then came deep learning starting in 2012. It wasn't until 2014 or 15 that deep learning became popular. That's when the object detection started to gain attention, and face recognition started becoming more accurate, and accuracy could hit 99% or better. Also, speech recognition and language translation apps started popping up. Machine learning and deep learning changed the way industries deal with their customers, their machineries, their processes, but they didn't take away many jobs. In fact, more jobs were added to cope with the explosion of data. In December 2022, I was addressing a group of customers, about 40 of them in a room, and I mentioned ChatGPT. Nobody knew what it was. Some asked me how the name was spelled. A few weeks after that, ChatGPT exploded across the world. Suddenly, people could talk to AI, and AI could talk back. Gen AI brought about a level of democratization that changes everything. Anyone can ask AI to write, to paint, to code, to design something, and the list goes on. And in the last 1 year or so, we have moved into the era of agentic AI. Now we can give AI high-level instruction, and AI can break it down into low-level tasks to execute. What this means is that AI can take a simple instruction over phone or email, then break it down into tasks, execute them autonomously, and then tell you that it's done. Agentic AI has just taken off, and there are a lot more things it's capable of doing. Next, I'd like to talk about one of our customers, GetGo. They operate the largest car sharing platform in Singapore. They used to have a team of people to manually inspect the pictures sent in by their customers. 4 pictures each time they drive off, and 4 pictures upon the return of the car. The manual process resulted in a lot of delay for GetGo to address the damage issues with their customers, and that led to a significant financial loss for them. Hence, they embarked on this AI journey with us. Where we created some AI models with their data science team. The first model was to do automatic damage detection with great accuracy and response time, achieving something around tens of milliseconds. Next, we help to vectorize the damage information and then store it along with the part of the car where the damage occurs, the vehicle ID, date timestamp, name of driver, etc. With all this information, GetGo can get a view of the condition of the entire fleet of cars, plan for workshop repairs, etc. This is a quick snapshot of the Converge database where we store both structured and vector data in one place. The next use case is about getting AI to vectorize this CCTV footage so that we can search for things using natural language. In this case, we have people walking up and down the street, and we have a man pushing bicycle. So we enter the search string, which is a prompt to look for a man pushing bicycle. Behind the scene, some similarity search was taking place to bring out results that are similar to what we are looking for. Recently, I talked about real-time AI at an event, and I would like to include this segment in this presentation. Have a listen. An AI model that is running close to this junction in an edge, right, at the edge, right, in this edge computing device. So the reason why you want to do that is because you want to have real-time response.
Apart from crowd monitoring, which is a simple example, I've talked to different customers about the importance of real-time AI. One of which is coming from a prisons officer. So this prisons officer was telling me that they monitor fights in the prison cells. Now they already have an AI model or the computer vision tracking what the prisoners are doing, and when they are fighting, they'll dispatch officers to the scene, right? But because this AI model is running at the distance away from the prison cells, so that means that the response time is longer. By the time the officers come to the scene is usually quite late, right? So that's one case of this real-time AI. The other one was a car manufacturer. So one of the use cases within this car manufacturing process is that they spray paint the cars, right, in the factory. And because the AI model, again, it was running some distance away, the response time is there, right, because of latency. By the time they detect any problem with the spray nozzle whatsoever, right, and try to rectify the problem, it's too late. Too many cars painted badly, right? So that's another one of the many other reasons why real-time AI is important. So looking at this workload, real-time AI workload, there are certain things that need to happen or detected, rectified at the edge. There are certain things that can be done in the cloud. Some information can be passed to the cloud to analyze, process, etc. Like in this case, we can do cloud density analysis, right?
Now that you have seen what real-time AI can do, let's apply that to a defense use case. Here we have a defense use case with some autonomous towers that have got the cameras mounted on them, and alerts are shown on the dashboard where we can click on one of them, which has detected 4 soldiers in uniforms, and we can look at the detail, which brings us to a screen showing what the camera was seeing, the 4 soldiers that were detected. And we can look at the details in terms of the time that was discovered and some classification and where it was detected, as well as the recommended action. And all this are done with the help of a large language model. And we can turn on the caption to see what the language model is saying. And let's go back to the dashboard. And we can pick up another alert, this time an amber alert with 3 figures spotted at night. And this is using a night vision camera. And here we can see the detail, the discovery time, classification again, and the recommended action. Going back to this dashboard, we see that there's another amber alert, a small inflatable boat that was spotted in the water at night. And let's look at the detail again. Here we have infrared capture of what's going on. And again, the detail on the right pane shows you all the classifications and the recommended action as well. So this dashboard gives you a perspective of what's going on in terms of this whole area that is being monitored, the timeline of what happened, all the incidents that were captured, as well as the threat detected with some detail given by the large language model. And you can put some of these things on a watch list, and it shows you all the threats by sensor, by event, wrap up, the AICEC helps translate problems into solutions. Feel free to contact us through Oracle Sales or use the email address on the screen to make inquiries. Thank you.